This topic is the introduction to graphing linear functions. Here are some vocabulary for you to know. The first vocabulary is a linear function. If you can just focus on the word linear, what you're going to see are graphs that are lines. We'll get more into what functions are later. The next thing is slope. You're going to hear this word a lot in this chapter. What the slope is the steepness of the line, how steep the line is. So the line could look like this, which means it has a positive slope. Or the graph could look like this, which has a negative slope. Or we could have a horizontal line, which has no slope. Or a vertical line, which our slope is undefined. You're going to also hear this thing called the average rate of change. The big word there is rate. When you see a rate in an application problem, a word problem, think of that as your slope. There's an equation that we use in slope to help us to find it. It's the letter m for the variable. And how you do this is take two ordered pairs and you subtract the y's and subtract the x's, and that's how you can find the slope. You can also find it by taking the rise over the run. The next vocabulary word is x-intercept. It's where it crosses the x-axis. The y-intercept is where it crosses the y-axis. We want both of these points as ordered pairs, not just the number 5. The last vocabulary piece is what we call slope-intercept form. Y equals mx plus b. This is your slope, and this is your y-intercept. So let's go on to a couple examples and decide, is this set of ordered pairs linear or not? Would it go out and create a straight line? So we want to see if there's a constant rate of change. So I'm going to decide how many places go from 2 to 5. Well, I'm adding 3. From 5 to 8, I'm adding 3. From 8 to 11, I'm adding 3. Notice that each of these numbers have a constant change of plus 3. Now let's go down to the f of x, or the domain we just talked about. Now this is the range. Going from 9 to 17, we are adding 8. From 17 to 25, we're adding 8. From 25 to 33, we're adding 8. Again, we have that same common rate of change of plus 8. So we would say, yes, it is linear, and y is it has a constant rate of change of rise and run. These are going to be our runs, and these are going to be our rises, the y values. In this case, we have a constant rise of 8 and run of 3, which will be in the end our slope. Here is a second example. Let's see if it would create a linear function. From 3 to 9, we get 6. From 9 to 15, we get 6. From 15 to 21, we get 6. So far, this run has a positive 6 change. Now let's talk about the y values. From 1 to 4, we get 3. From 4 to 10, we get 6. Uh-oh, what happened? These two are not the same. So we would say that this would not create a linear function. So it is a no, does not have a constant rate of change.